Hey everyone, welcome to TDX. Hope you're having a great time already. You'll have an even better time during this session. Thank you for joining us. Today, we are going to be talking about the Einstein Trust Layer. Before we jump any further, forward-looking statements, please make all your purchasing decisions based on generally available information and not based on what we share today, because some of what we are going to talk about is not yet GA. All right, so who are we? My name is Aditya. I'm a developer advocate at Salesforce, and today I'm joined by Shivansh, who is the PM for the Einstein Trust Layer. So why are we talking about the trust layer? So when you talk about the Salesforce AI architecture, the entire product suite of our AI offerings is built on top of the Salesforce platform and the unified metadata layer that all the other Salesforce apps are also using. So what it really means is that AI features can take advantage of all the security features that you already know about. Like you have profiles, permission sets, field level security, so on and so forth. All of that is already being embedded into Salesforce AI. But then what's the number one concern for customers? It's not that the security model within Salesforce is not going to work for them. It's that they are concerned about their data leaving the trust boundary of Salesforce and going out to an LLM. Because these days when you talk about generative AI, there's always an LLM, and the data is leaving the trust boundary of Salesforce to an LLM. And how do you secure that? And that's the exact reason why we built the Einstein Trust Layer, and we made it a part and parcel of our AI architecture. Now, what is a trust layer? So a trust layer is nothing but it's a bunch of tools, it's a bunch of processes, and it's a bunch of policies. So it's a combination of all of these three that ensure your prompts and the data are safe when they move out from Salesforce, hit an LLM, and come back. So at a very high level, if you notice, there's a lot going on because there's a lot that has to go on to ensure your prompts are safe. So first and foremost, when you're talking about a prompt, it has to go and hit an LLM. What's the first thing that you want to do? You want to ensure the prompt has the right set of data. So what we offer with the trust layer is dynamic grounding, which means we get the data that is at that point in time, whatever is the latest data that you have, that's going to come into the prompt. And what we also do is secure data retrieval. So here is where your standard Salesforce security implementations are going to come into picture. Like if a running user has access to a particular field, only then it's going to be put into the prompt template. If they have access to a record, only then it's going to be put into the prompt template. If not, no. So that's how it works. Now, after you put in all of the data into your prompt template, you write a bunch of instructions, then there is a scope of prompt injection. So just like when you talk about web security, there are these JavaScript injection attacks. For prompts as well, there are injection attacks that are possible. And Trust Layer helps prevent those. Now, once the prompt is ready, it is secure, tamper-proof, then what we do is one of the most important steps, which is data masking. So what it means is that a prompt, you've added all the data that you want. But this data is valuable to you, and it should never go out to an LLM. So what we do is any sensitive data that is there, we convert it into tokens so that the LLM only sees tokens, but not the actual values. You're going to learn more about this through the session, but that's what is going to happen. Now the prompt is going and hitting an LLM, and the response is getting generated by the LLM. Now what we have with the LLMs that we have onboarded onto Salesforce is a zero retention agreement. So which means they can neither retain the prompt, nor can they retain the response and use it for any of their training purposes. So it's absolutely zero retention from the LLM end. Now once the prompt comes back, we are obviously going to demask it because you as a customer, you need to know what the data is. The LLM doesn't need to know. So we convert those tokens back into legible values. And then all of this process is logged. So every single step that goes on through the trust layer, there is an audit mechanism at any given point of time. You can see what is happening behind the scenes. So at a very high level, this is what we have. But let's dive into each of these topics. First and foremost, Any prompt that goes out from Salesforce to an LLM using our Salesforce technologies goes through the trust layer. So whether it is Agentforce, whether you're calling the prompts to Apex, or if you're using Models API, all of these go through the trust layer. What is the one piece that doesn't go through the trust layer? Is if you call a third-party LLM directly. So let's say you write a flow or an Apex, make a call to an OpenAI endpoint, that's when it doesn't go through the trust layer. So our recommendation is always to use prompt templates or model API so that you are leveraging all the security features that we just spoke about. Now the first feature that we want to talk about is secure data retrieval. Now in order to do that, let's look at a very simple prompt template. So what we have here is a fictitious customer called Trailblazer Outfitters. They are a retail company, and they have a customer who's placed a bunch of orders, raised a bunch of cases, and you quickly want to see a summary of what all is happening with that customer. So what we built here is a very simple prompt template that includes some merge fields. We are getting all the details of the contact. We are using Apex to get a bunch of related details. And what happens the moment you preview it? So let's say you select a particular customer, you hit on preview. What happens is two things: secure data retrieval and dynamic grounding. What it means is the Apex classes flows that you have embedded are going to run at that point in time and fetch the current data to ground your prompt template. And when this happens, we also respect user permissions. So if a user cannot see something, that's not going to be retrieved into your prompt template. Now, so because of the resolution, I don't think you'll be able to see a lot, but notice there is a bunch of JSON going on here, and then you have a nice little response that is coming out from the LLM. Now, let's say you're invoking this prompt template from an agent. It's still going to respect all the user permissions. So how is it going to look like? If it is user 1 who is running the same prompt template, they see a whole bunch of details depending on their level of access. Switch on to a different user, then depending on their permissions, the data that they see comes down. Now, the next important step that I mentioned is going to be data masking. So what is data masking? As I mentioned, it's going to be converting all your sensitive data into tokens. And all of this can be configured right within Salesforce. So it is in your control on what data you want masked. So within Salesforce, you have an option in setup called as Einstein Trust Layer. So here is where you can enable data masking. And here you can choose between two types of data masking. One is pattern-based, and the other one is field-based. So in all of your prompt template, we do a basic pattern detection. If we find something that looks like a phone number, a company name, credit card details, we automatically mask that. But let's say you have your own custom fields that contain sensitive data that might not necessarily be in the format that we expect. So you can choose that the data on these fields has to be masked. So that's where field-based masking comes into picture. And you can choose what kinds of fields are masked. For example, any field with the compliance category PII should be masked, or with data sensitivity levels and so on. But what are these compliance categories and data sensitivity levels? So all of you have created custom fields, and I'm sure most of you have left these two fields as blank: data sensitivity level and compliance categorization. So this is going to become important now. Go back, look at your orgs, set these values, and then you can choose that these kinds of values will be masked by the trust layer. So that's what we have. And if you notice this prompt that we were just looking at, there is a warning or kind of a message here that says there is some data that is masked here. So if you click on this link, you can actually see what data has been masked when it has gone out to the LLM. So here we have replaced your credit card number, email address, my name, the other person's name, and some custom fields as well. It shows you what kind of a masking we have done. Now this is within Prompt Builder. As an admin, you can go click through and see that, okay, this data has been masked. But what about real-time prompt generations? How can you keep a track of what data has been masked and what not? So that's where audit trail is going to come into picture. And as I mentioned, every single operation within the trust layer is logged by the platform. And there are a bunch of different data model objects that we use in order for logging. So notice I mentioned the term data model objects. So these are not custom objects, which means we are using data cloud for all of this. So these objects store everything that is going through the trust layer. Now, to give you an example, so we have a data model object called Gen AI generation. So this object typically shows you what is the prompt that has gone out, what is the prompt that has come back, what data that we have masked, and so on and so forth. And if you take a look at a very high level, you'll notice you won't understand a whole lot of it because there are a bunch of different fields not formatted properly. So what we've done to make it easy for you to understand what's going on is we've built reports on top of these data model objects. And these are out-of-the-box standard reports that you get, which you can access. For example, if you open the masked prompt template and response, in just a bit, you will be able to see the data about all the different kinds of prompts that have gone out. And notice this particular one is interesting. So the prompt is actually starting from somewhere here. But what is all this random text that we have added before the prompt has gone out? So this is for grounding. This is that prompt injection prevention, all of that. So you actually get to see what is the prompt that we have used behind the scenes. And this is the masked prompt. And as you can see, there are masked values like person1, person0, and so on. And then there is the response that has come back, and what is the masked response, how we have unmasked it, and so on and so forth. So a pretty detailed report is available. It's not just report, but you can also see a dashboard built on all of these reports. For example, it shows you a summary of what all fields we have masked, what compliance categories, and so on and so forth. Now that was about data masking. Now the other feature that I want to talk about is toxicity detection. Now this is again a phrase that goes on in the LLM industry where the text that you send to an LLM or the response that comes back can be categorized as toxic. But what does it really mean when we say toxic? Is that we actually have an algorithm or a detection model that runs behind the scenes that looks at the prompt text and response and rates it based on all of these different categories: hate, identity, violence, physical, so on and so forth. And all of these metrics go on to calculate the toxicity level of a particular prompt. Now what happens if a prompt or a response is found toxic? We surface it as a warning. So whether it is in your builder, whether it is in agents, whether it is in prompt templates, there is a warning that shows up to the customer saying that there might be harmful content. Now how can you keep a track of this? This is in the UI, but if there are developers and admins in the crowd, let's say you make a call out to the prompt template endpoint, you can actually see the toxicity scores coming as a response. So if you're using Apex or any other mechanism that you're going to use, even with flows, if you call to a prompt template, you can actually see the toxicity values and then take a decision on whether you want to surface that prompts to end users or not. And as I mentioned, all of this is logged. So you have another data model object in which all of these toxicity scores are marked as well. For example, you see the safety score, identity, hate, so on and so forth. All the values are logged. And the dashboard includes details for this. So this was for data masking. If you scroll a little bit down, you can see the toxicity of all the different prompts that you have sent out so that you can keep a track of what's going on behind the scenes. So that is, in a nutshell, about some of the features. And of course, feedback is really important. As and when there is a prompt that is sent, you get a response. You'll notice a thumbs up, thumbs down icon. Anywhere you see a response, you as an end user get to tell us, what do you think of the response? Do you like it or not? And of course, that is going to be logged. And you can do this not just through the UI, but if you want to let us know through Apex, if you want to make API callouts. So there is a bunch of different ways in which you can give feedback on a given response. Again, all of that can be logged. So you have a different data model object. You can see all of this. So in a way, what we are trying to tell you here is there are all these operations that are happening in the trust layer, and all of these are completely transparent to you and us both. So you can see what's happening behind the scenes and configure it. Now, I want to hand it over to Shivansh, who's going to talk about a brand new feature that has come out that is specific to Agentforce, which is called Agentforce Guardrails. And I'll hand it to you to talk more about it.
Thank you so much. Thank you so much, Aditya. So Aditya did a great job talking about the Einstein Trust Layer, which is our robust framework to secure your LLM gateway applications, the generative AI applications. But now we've entered into the agentic world, haven't we? And that begs a question. What is trusted agentic behavior? And once you've defined what trusted agentic behavior is, then the next question is, how do you steer your agent towards trusted agentic behavior? We've spent a lot of time in the last couple of months trying to figure out and define and package our learnings about trusted agentic behavior into key themes. And I want to quickly share those themes with you before I show you a demo. The themes that we've packaged around are, first, policy adherence. If you're telling agent what to do through your organization policies, then these policies change over time. How do you make sure that the agent adheres to these policies? Could be your brand values, brand integrity, organization policies. And as these are evolving over time, which they will as your business grows, how do you make sure that the agent can dynamically adapt to it? Then there's this human-agent teaming. How do humans and agents work together with each other? What is that gentle blend of human oversight with agentic automation? Then you've got the end-to-end stack of observability, from design time to runtime to testing, operational controls to make sure how many concurrent conversations can an agent have at any point in time. If someone's trying to rabbit hole an agent, more than 50 turns of conversation automatically leads to an escalation. How do you set these operational boundaries and controls without really compromising any of your ethical or legal boundaries? And then you've got these table stakes that we just talked about: safety, security, privacy, sensitivity, legal compliance, and ethical compliance. These are all of our learnings packed into what defines trusted agentic behavior. So now that we've set that base for what defines trusted agentic behavior, the question is, how do you steer it and how do you implement it? And that's where I'd like to introduce Agentforce Guardrails. Agentforce Guardrails are a set of features, controls, and policies that do two things. One, positive reinforcement of trusted behavior. When the agent's doing well, give the visual cues and reward systems within the brain of Agentforce, which is Atlas Reasoning Engine, and double down on it. And then the second part of it is, when there's deviations, how can you accurately and quickly detect these deviations, explain and reason about these deviations, and then course correct to bring the agent back onto the rails. And there's a set of features that we have within the Atlas Reasoning Engine. I want to dive deeper into the architecture of the brain of Agentforce, which, if you saw the keynote today, we spoke about the Atlas Reasoning Engine. Within the Atlas Reasoning Engine, let's try to understand how all of this is really working. You've got the user query coming in, right? And then it goes through the Einstein Trust Layer that Aditya just spoke about. And then it goes to the planner for all of the planning, for what steps need to be executed, what topic is relevant to this query, what actions need to be executed. If there's any additional context through RAG, let's do that. Let's refine that context to ensure we really understand the user query. Hit the LLM, get the response. Once you get the response, then you see the block that says output evaluation and guardrails. A series of checks happen here. Is the response grounded? Is the agent following the instructions provided to it? If you're telling agents what to do through topics and instructions, then the question is the agent following those instructions or not? And if not, then what can we do to steer that agentic interaction? And only when all of these checks go successfully is a response then served to the end user. If not, if your query is not satisfied, then it can lead to an escalation. Okay. So now that we have that understanding, I want to talk about the pilot that we launched last week with some of the biggest customers for Agentforce. AI-assisted instruction adherence. Again, if you're telling agents what to do by giving them topics and instructions, the question is, are they following the topics and instructions? If not, can we reason about it, fine-tune our topics and instructions to improve that? If any of you are interested in joining this pilot, just grab me after this session, and we'll talk about it. But let's do a demo now. Okay. I've got a very simple agent configured here. It's a service agent with simple jobs like look up my order details, schedule my deliveries. Most of the topics are like default topics and instructions that I've configured. I might have added a few instructions here and there to ensure that the agent is not interacting with customers for any private information or any personal PII information and things of that nature. But most of it is just default configuration. All right, so I'm going to start with a very simple query which says, get order details. Very simple query. Now we remember the brain of the agent, right? What happens here is it hits through the Atlas reasoning engine, which is going to classify a topic for this particular instruction. It's going to pick one of the default topics that's already been configured, and then execute the instructions for it. So let's look into it. The agent says, sorry, I had trouble coming up with a response for your request. Could you please try rephrasing your question? That's a little bit embarrassing because that was a very simple query, right? That should have been a simple response. So what happened here? Let's debug. We're admins. We're going to debug this. OK. If I look into the reasoning here, I'm going to expand this block. There's a bunch of information. First, it says the actual generated response was, could you please provide me with your order number so I can look up the order details? That was the actual response, which sounds like a reasonable response to a query like that, get me order details. But it was never passed to the end user. Why? It didn't satisfy the checks in guardrails. It was an ungrounded response. The response asked the customer to provide their order number, which is explicitly prohibited by the context. So when the admin was developing this agent, which we're going to look into, they provided some extremely restrictive context, which prevents the agent from fetching this information. Instruction adherence is also low because the agent is asking for this information, which is a clear violation of the instructions. All right, so let's look into the instructions real quick. We're developers, we debug, right? So when I open these instructions, I see this particular instruction here says you're never allowed to ask user for this information, which is email address, phone number, delivery address, or order number under any circumstances. Okay, good intent, but it prevents the agent from being productive because for the agent to run actions like identify someone's contact verification or fetch order details, it needs this information. I'm going to open up this instruction a little bit and say you're only allowed to request for this information if it is required to look up order details or contact record. Now, these are the two actions that I've configured here. If there are more actions that you've configured that require this information, we can add that information in here. But we're basically adding a condition to this topic, instruction. OK, now that I've done that, I'm going to refresh this session. And I'm going to ask the same query, get order details. Same process. The utterance goes through the Atlas reasoning engine, and the Atlas reasoning engine is going to figure out the right topic for it, which should be the same as last time, but this time the agent responds in a productive way. Could you please provide your email address and the order number so I can look up your details? As you go through this, you see that the reasoning is both grounded and the instruction adherence is high. This is what you want to see more of. You also have the explanation here. If you don't agree with this explanation, we're very soon going to add thumbs up, thumbs down, so you can tell us when we get it wrong. And we can fine-tune this together. OK. So now I'm going to continue with this conversation for the sake of it, because I'm enjoying it. I'm going to say, OK, here's my email. And I still expect the agent to remember what the original job was, which is get me my order details. But to get the order details, it first needs to verify my identity. And that's what the agent did in this particular case. And it said that before looking up your order details, let me verify your identity. Identifies the customer by email. And I can go on with this and say, hey, can you look up my order by my email? And the agent will respond to it. But the gist of it is reasoning block. This is what I want you to look at. And for admins and developers who are building an agent and testing an agent under different situations, we're adding more information here that is both insightful and actionable for you to make sure that the agent can be steered towards trusted agentic behavior. Not only can you find this information through the agent builder, but you can also find this information through the event log. So you can go into the event log, see trace by trace, find the output response evaluation, look at the metadata, and that's not it. We also log all of this information to our very beloved audit trail. All of this information is available in audit trail, so you can pre-build your reports, you can schedule your reports. On top of that, you can set flows and alerts to notify your admins. Hey, I've noticed your agent's been encountering more than 50 ungrounded responses in the last 24 hours. You might want to look at that. That could be one example, and there could be many other examples, and we want to make it simpler and easier and more integrated. But I'm going to pause here for this demo. Again, if there's anyone interested in having a deeper conversation on this, you'll find us right outside this session. We've got 5 more minutes. Should we show them a sneak peek of what's coming next?
We are out of time, so we'll just do the slides.
OK. So we are on the final slide. This is what's coming up in the next coming months, couple of months. You can take a screenshot and find us outside. Thank you so much, Aditya, for leading us for this session. And thank you so much, everybody, for joining us.
Have a wonderful day, and hope to see you in a different session today or tomorrow.